Okay, worksheet due Friday. We'll finish the notes tomorrow. I won't be here, and then you work on the worksheet. So your warm up was to figure out what the natural log of 29 is, but let's think about what an approximated answer could be. We can always pin it between two integers. So first of all, the natural log is base what? E, right? So if you want to write that as log base E of 27, and then say it equals X, right? That's what we've been doing. You can convert it. E to the X equals 27 or 29, sorry, 29. Oops. And now again, we know E is 2.718. So we can think of E, for the sake of approximated purposes, we can think of it as approximately 3. So 3 essentially to what power is 29? 3 to the first is 3, 3 squared is 9, 3 cubed is 27, 3 to the fourth is 81, right? So 27 is the lower bound, 81 is the upper bound. So it has to be between 3 and 4, and probably closer to what? 3 or 4? Yeah, probably really, really close to 3, because 29 is just a smidgen larger than 27, much closer to 27 than 29. So it's always good to think about that, right? There goes my drum set. I caught it though. I caught the set. Uh-oh. I may need to relocate it. Yeah. Oh, yeah. I can this morning. There we go. Now we go to the calculator. Oh, what I was saying. Oh, yeah. The purpose of this class is to get you to think. So if you're never not thinking, you're not doing what you're supposed to in here. Got to reload my ROM. If you're still having problems with loading this, like some of y'all emailed me, but then you figured it out, like Colin, you said you figured it out finally. If you're still not able to get this on your calculator, come see me during tutorials, because it's really nice to have this, right? Wherever you go. And if you happen to have an Android phone, you can get a nice colored version of this on your Android phone as well. And I could show you that. That's really the only reason I'm keeping my Android. I haven't switched to Apple phone yet. All right, so LN is right there to the left of 4, 29.
Sorry for the interruption.
No
but
problem.
I just want to let everyone know that bus 59 is just arriving. Bus 59 is just now arriving. Thank you.
Right, I know that bus driver, right? 3.369. So yeah, there it is. It is closer to 3. And with the calculator having all those decimals stored, we can actually confirm that by saying E, second ln, right? Second ln, and then we can recall the answer that's in the previous line by hitting second negative. And that recalls the answer from the previous line with all of the decimals still stored. And when you hit enter, you should get 29, and you do. Okay. Yeah, if you just typed it in by hand, of course, 3.367, you're not going to quite get 29, because that's called rounding error. Yeah. So when at all possible, we want to store values or use stored values. So the calculator automatically stores the previous line. But just to review, right? If we had natural log of 29 and we get that and we want to store it as something, we could hit stow, which is just to the left of 1. And then we could choose any letter from the alphabet other than X. I like A because it's alpha A. It's right there. Store alpha A, boom. And now it's locked in as A. And if we call it A on our iPad or calculator, we can call it A on our paper, right? And so now you can go second trace, or not second trace, sorry, E, right? E to the alpha A power. And there it is, right? Storing values. It's a really, really important skill set. All right, everybody warm? Warm, yeah, okay. My poor dogs, they were inside for like a year and a half of the pandemic because there was always someone at the house. They're inside outside dogs, always during the day when no one's there, they're outside. Then my kids were home from college for like a month, and so someone was home. They were inside all day long again. Just when they got used to being back outside during the day, now they're inside. Well, guess what happened this week? Got to put them back outside. And dogs, they're born with a fur coat, unless you get like a Mexican hairless Chihuahua. So they go outside and it's like 45 degrees, which they're fine, but they're like shivering, like, holy crap, if you go to work and leave us, we're going to die. And I have to tell them, no, you're not going to die. You got a fur coat and you got a doghouse that you don't go into either. So quit complaining, use your resources. But anyway, I had to leave him outside again today, and the little one was shivering like a chihuahua. And I'm just like, he'll be fine. He'll be fine. Run around. They chase deer in the backyard. So if the deer are fine, like in free, where do the deer go when it freezes? You don't ever see deer congregate like under an underpass from the thing, right? Huddled together. No. Creature comforts. That's what we call it, right? Creature comforts. Comments or questions on the warm up? Speaking of being warm, that's how it came up. All right. Change of base formula. So I was talking to you yesterday about how your calculator is pre-programmed to handle base 10 and base E. That's it. LOG and then base E. But what if I want to evaluate something like this? What if I wanted to find log base 5 of 138? Log base 5 of 138. Let's see what approximately that is first by thinking. 5 to what power is approximately 138? 5 to the 5th is big. 5 to the 1st is 5. 5 squared is 25. 5 cubed is 125, right? And then 5 to the 4th is bigger than 125. So this should be 3 point something again. Yeah, because 5 cubed is 125. 138 is a little bit bigger. But where's the log 5 button on the calculator? There is none. Okay. So here's what we do. There's something called the change of base formula. And here's what it says in general. Log base b of x for any legal base between 0 and 1, greater than 1. You can rewrite it in terms of any base you want, Okay, we're going to write it in terms of base e because that's the one that we're going to start trying to use. So all you have to do is take your new base, which we're choosing base e, so the natural log of the argument over the natural log of the base. That's it. Log base b of x is equal to the natural log of x over the natural log of b. So it's pretty easy to remember which one goes where, because if you notice, the subscript is written below the argument, right? It's a base. So the base goes on the bottom and the argument goes on the top. Okay. Now, if you don't want to choose base E, you can choose base 10. So you could also do log base 10 of the argument over log base 10 of the base. Okay. Now, remember that when you say that two quotients are equal to each other, that doesn't mean that the numerators are equal, right? And the denominators are equal. Like 2/3 is equal to 4/6, but 2 doesn't equal 4 and 3 doesn't equal 6. But the ratios would be the same. In fact, if you want to choose a different base, like A, you could choose it, log base A of X over log base A of B. If you're not trying to evaluate, maybe that's what you want to do. You want to convert it from a base 5 log to a base 12 log. It's like a Google Translate, but for logs and not on Google. Just like it. Other than that. Okay. So let's come over here and try out this problem I gave us. Log base 5 of 138. According to the change of base formula, it should be equal to the natural log of something over the natural log of something. What goes in the top? The 138 or the 5? And then the 5 in the bottom. Yep. All right, let's try it. Turn your calculator on. Use the horizontal division bar. Y'all can do alpha x. ln of 138. It opens the parenthesis for you, so you get in the habit of closing it. And then in the bottom, the natural log of 5. And you hit enter, and there it is. Lo and behold, 3.061. Pretty nifty, huh? Pretty nifty. Now, what if you're like, nope, sir, in my family, we're categorically against base E, right? So let's use base 10. Log base 10 of 138 over log base 10 of 5. Let's try it. Alpha y equals, boom, we got log of 138 over log of 5. Hey, we get the same answer. Now, again, what I was saying earlier, that does not mean that the natural log of 138 is equal to the natural log of, or the natural log of 138 and log of 138 are not equal to each other, but their quotients are the same. Okay. In fact, if you want to pick a third party base, what's another number besides 5? Are there any other numbers other than 5? 6. Good. Let's choose 1/6. How about that? This is equivalent to log base 1/6 of 138 over log base 1/6 of 5. Now, unfortunately, we can't type that into our calculator unless we change the base in the top and the bottom into the natural log, but it is equivalent. It is equivalent. Okay. So believe it or not, if you have the new math print, which all your calculators do, there is another way to type it in with a different base, but I'm not going to show you because I don't want you to use it. I want you to use the change of base formula. Huh? But now you're going to go home and look up a YouTube video on how to do it, right? That's fine. I'll ask you to use the change of base formula. And when I ask you to use the change of base formula, I'll always tell you to show what you're typing into your calculator. So you're not just going to have log base 5 of 138 and underneath there put the answer. You're going to have to show me this right here. Okay. All right. Well, that's pretty easy, right? That's a pretty easy formula to look up when you need it, but it's better to have it up here. So memorize it. Okay. Memorize. It's easy to memorize, right? There's really nothing to memorize. It's like trying to memorize how to walk from here to there. Is it left, left, and then right? Or is it right, right, right? Or is it left, right, or right, right, left? Either one. Oh, yeah, I don't have to memorize that. I just do it. See? Great analogies this morning. Okay, example 4. Evaluate the following to 3 decimals on your calculator. Show your setup and try to think of a reasonable answer before you type it in. I'll give you 3 minutes, 1 minute apiece to do these on your own. On your marks, get sets, and go. All right, so for the first one, log base 1/2 of 14. Here's me off to the side thinking beforehand. I didn't set it equal to x because that's my bench work, but if you set it equal to x, you can convert it. 0.5 or 1/2 to the x power equals 14. Well, I know that if I just look at powers of a half, positive integer powers, 1/2, 1/4, 1/8, that's going to make it smaller. I need to get the 2 into the numerator, so I get 2, 4, 8, 16. So I know that's going to be a negative, right? I know with a negative, it'll flip it. Now I look at the magnitude, powers of 2. 2 to the 3rd is 8, 2 to the 4th is 16, right? So it's got to be 3 point something, put the negative in front to flip it, and it's negative 3 point something. And now I'll go over here and I'll write it, natural log of 14 over natural log of 0.5. Again, your calculator is going to open the parentheses for you. So it's a good habit to get into closing it before you scroll down. And sure enough, there it is, negative 3.807. Okay. Try to use the horizontal division bar. And again, you could have used log, but I encourage you to use natural log. All right, the second one, log base 6 of pi. So me again off to the side of my bench work. That's 6 to the x equals pi. If I look at powers of 6, 6 to the 0 is 1. That's too small, right? 6 to the 1st is 6. That's too big. So I know it has to be between 0 and 1. Now, that's going to be like a 1/2. The square root of 6 makes it smaller. The cube root of 6 makes it smaller. I don't really know if it's going to be between 0 and 1/2 or 0 and 1/3, but I do know that it should be between 0 and 1. So now I set it up, natural log of pi over natural log of 6. And again, when you type in pi, don't type in 3.14 because we already talked about trying to use as many decimals as possible. So second pi, your calculator has it stored, and you get 0.638, which if you're into rounding, 0.639. Do we really need the 0 in front of the decimal there? Is it needed? No. I like to have it just because to me it helps offset the decimal, it makes it look more intentional. If you just put a decimal, sometimes it looks like a stray mark. And I don't know if you're talking about the number 639 with a booger in front, or 639 thousandths. All right, then the last one, pretty easy, 3.6 to the x equals 17. Again, when it's a decimal like that, you can think in terms of like 4, right? 4 to the 1st is 4, 4 squared is 16, which is still too small. 4 cubed is way too big, 64. So I know it's going to be 2 point something, and I put 2.211. Is that right? If this were a quiz or a test and you're grading my work, you can see off to the side, I've thought about it and I put the answer. You giving me full credit? No, I hope not. Hope you're going to take off one check and be like, where the heck did 2.211 come from? Did your grandmother mail it to you from Minnesota? And now you're showing it. Is this show and tell day? Where did 2.21? What did I forget? I forgot to tell you where it came from, right? So I guess I'll leave a lot of space in here and I'll say like, once upon a time, my grandmother sent me something from Minnesota, right? No. I mean, that would be kind of crazy coincidence if that actually happened, right? The natural log of 17 over the natural log of 3.6. Now I'm like, oh, now I know where that's from. Now I know where that's from. It came from there, right? You always got to show me. So it's good habit, again, to get into. Anytime you have a calculator at your disposal, always have written down on your paper first what it is you're going to be typing in, because that's the thinking part, right? You're doing all the thinking beforehand, you're getting it set up, and then the calculator is really, in this case, just the number cruncher. It's the heavy lifter. That's it. You box everything up, all good. All right, questions on those. Those are easy, right? If I gave you a test tomorrow over like 150 of those, I want to make 100 easily, right? As long as your calculator was charged or mine were charged. What if I unplugged the chargers tonight and then gave you that test tomorrow? Y'all would be fine. But second period, maybe third period, ooh, over the course of the day, the battery power is going to decline. I would hate to be in Miss Corpy's fifth period class with, yeah, just wild scenarios that'll never happen. Thanks for tolerating me, guys. All right, example 5. Simplify the following using the change of base formula. Okay, how many of y'all are getting excited about typing that into your calculator? Ooh, right? Yeah. Well, the prerequisite before we even go to the calculator, since it's base 3, 2, 7, and 5, which our calculator cannot handle directly, is to what? What's that? Yeah, get the bases the same all the way across by using the formula that allows us to change the base, which is called the change of base formula. Unless you're in Ireland, then it's just called the change O base formula. Yeah. You know, I was 46 years old before I realized that Ireland has their own language that's not just English with an accent. Yeah, it's a very sophisticated language. I always thought Irish people just talked like leprechauns with English words, but no, there's a language. Yeah, I was 46. I learned that last year. So you're never too old to eradicate your stupidity, your level of stupidity. Because I should have known that, but you know, in my defense, I've never been to Ireland, so I wouldn't know. All right, here we go. The natural log of 5 over the natural log of 3 times the natural log of 7 over the natural log of 2. Notice what I'm doing here. I'm putting multiplication dots instead of parentheses. You're more than welcome to put parentheses, but it gives it kind of a lighter look. And now who's excited about typing that into your calculator? Ooh, I am not. By breaking down the walls, before we go to the calculator, we should simplify according to the same model that Chicago has for voting purposes, right? Early and often. Chicago's voting mantra: vote early and vote often, right? More than once. That's a corrupt government joke. Yeah. We should simplify early and often. I don't want to have to type all that stuff in, but once we tear the walls down, since it's one big term with multiple factors, remember, common factors will divide out. Do we have any common factors? Yeah. Holy crap-a-moly. We have a few common factors, don't we? All right. Let's see what that looks like. I'll use red. Natural log of 5, see ya. Natural log of 7, see ya. Natural log of 3, adios. And we're left with the natural log of 11 over the natural log of 2, which, if I want to approximate that, that's a lot easier to type into the calculator. Indeed it is. So now let's do that, okay? Come down here. alpha y equals enter, or alpha x for y'all. Maybe. 2 to what power is 11? 2 to what power is 11? 2 to what power is 11? Before I hit enter, why if I see the natural log of 11 over the natural log of 2, why is it reasonable for me to think about the answer as saying to myself or asking myself 2 to what power is 11? Fantastic, Hayden. That change of base formula, it works both ways, right? Just like a telephone call to a loved one. It works both ways. If you feel guilty about why you haven't called a loved one, realize that they haven't called you either. So don't feel guilty. That's log base 2 of 11. Yeah. And now if I set it equal to x, I can say 2 to the 11th power, or 2 to what power is 11. So it should be what? 2 cubed is 9. 2 to the 4th is 16. So it should be 3 point something between 3 and 4. Yeah. 2 cubed is 8. Thank you. I'm thinking 3 squared. I got them backwards. Yeah. That happens. That's called mathematical dyslexia. Yeah. I get my numbers backwards, right? Yeah. It was funny. It's funny. When I was 18, I walked around like I was an 81-year-old man. Where's my glasses? Where'd I put my cane? Because I was 18 and I thought I was 81. So yeah. I just made that up. Yeah. Thank you. So yeah, it should be 3 point something, because 2 cubed is 8, and then 2 to the 4th is 16. So now we'll type it in, we'll hit enter, boom, and there it is. It's 3.459. There you go. This change of base formula, wow, it's pretty handy dandy, isn't it? Handy dandy. Simplify early and often. Okay. Now, that's not the only application of the change of base formula. The change of base formula could be pretty applicable to graphs as well. So let's go ahead and put that off until we get to graphs, though. Okay, and then we'll revisit that. We'll revisit that later. Yeah, I'll do it after I get through this right here. Example 7 returns to we'll return to the change of base formula. Okay. So for right now, let's look at example 6. I kind of went a little out of order. Example 6, so I kind of already talked about, because we did that little delta math activity, and I was going to wait to do that. Ms. Lincoln thought it was a good idea. So let's go through example 6 quickly. We can solve logarithmic equations, and the variable can be in any one of those 3 places. It could be the base, it could be the argument, or it could be the log itself. And in any case, remember, the way that we solved it, the easiest way to solve it, the most intuitive way to solve it, is to simply convert it to what? The other form, exponential. So let's do that here. It says to solve each equation for z. All right. I just chose a different variable. All right. So here we go. We got log of z equals 3. That means it has a base of 10. Is it okay to write the 10 there? Yeah. Now that you see the 10, now it seems easy to convert, right? 10 to the 3rd equals z. And so z equals 1,000. Wow, that's easy, right? So if you remember from our little thing yesterday, when your unknown is in the argument and you convert it to exponential, it's pretty much just evaluate then, right? Because you already solved it for the variable. Yeah. So that's an easy one. Now, this thing that we're taking the log of, it doesn't always have to be a single variable. It could be an algebraic expression, like on letter B. Try letter B on your own. On your mark and set, go. All right, so we have another log equation. There's a variable in the argument, but it's not just a single variable. It's a z plus 1. But we see the base is 2. See the log is 4. We'll convert it, right? So 2 to the 4th equals z plus 1. You don't need to draw the little arcs when you travel around the world. If it's fun to do that, feel free, but you don't need to. And now we're like back in algebra 1, right? Maybe day 2. Day 1 you used x's, day 2 you used z's maybe. 2 to the 4th. See how I put a line through my z here so I can differentiate from the 2. 2 to the 4th is 16, so we get 16 equals z plus 1. And now to solve for z, we just subtract 1 from both sides. 16 minus 1 is 15. And there it is. There's the answer. It's not only fun, it's easy, right? It's fin easy. Yeah, it's fin easy. Okay. Let's do this one here. Give you a shot at doing it yourself, and then we'll talk about it. It's a good way to proceed. All right, so let's see. Finishing off here, A, B, C, D, and E. We've got 1/2 to the 5th power. Again, if this is a formal writing, I would put any fractions in parentheses, and that equals the argument 2z plus 3. If you don't put it there, and I didn't do it on my bench work earlier, you probably saw that, but if you don't put it there, it kind of looks like it's just to the numerator, right? Which is very different. So better to have them and not need them than to need them and not have them. All right, now, finish this at 1/2 to the 5th, 1/2 to the 5th. That's 1 to the 5th over 2 to the 5th. That's 1/32 equals 2z plus 3. Now, at this point, you're at a fork in the road. And as Yogi Berra said, when you get there, you should take it, right? You might just complete your silverware set at home, right? When you get to a fork in the road, take it. You can either embrace the fraction, work with the fraction, or you can eradicate it. What do you want to do? Embrace it. Wow, okay. Right, embrace it. Oh, hug it. Yeah. If you're going to embrace it, then you're going to subtract 3. So you get 1/32 minus 3 equals 2z. And now you need a common denominator. So we're going to have to multiply this one by 32 over 32. And so we get 1 minus 96, which is negative 95/32 equals 2z. And now instead of dividing by 2, since we have a fraction on the other side, I'll multiply both sides by 1/2. And now we get z equals negative 95/64. That's embracing the fraction. If you need practice working with fractions, don't run away from them. Yes. Negative 1 point something. Yeah, I don't. Did you get negative 1 point something? You could do the division. Did anyone else get negative 95/64? You did? Let's see. If you're really good at fractions and you tell yourself you don't need the practice, okay, then you can eradicate it by multiplying both sides of the equation by 32. Okay, you multiply both sides. It's like the lick 'em over lick 'em strategy for getting rid of complex fractions, but it's the equation version. You multiply the left side by the lick 'em, and you multiply the right side by the lick 'em. Okay, and what that does is it divides out to give you 1. And now if you distribute here, you get 64z plus 94. And now you subtract. Maybe I did do it wrong over there. Subtract, and I get negative 93 equals 64z. And now I can divide through, and I get negative 93/64. Uh-oh. Oh, there you go. Thank you. I was going to say that should not be right. Good catch there. Yeah, because 3 times 2 is 6. You know what they say? Haste makes waste. I just wrecked myself because I did not check myself. Now, thank you for catching that. Had I done it 2 different ways, which again, I would not dissuade you from ever doing something more than one way and comparing your results. If you're expecting the same results, one of them's wrong, that gives you the ripe opportunity to troubleshoot, right? Yes. Why you using the natural log? What do you mean you use the natural log? Did you convert it to exponential? But if you convert it to exponential, like we did here, you wouldn't even have a log anymore. Yeah. I mean, really, the only thing you could do if you want, you could use the change of base formula, the natural log of 2z plus 3 over the natural log of a half, and then let that equal 5. I mean, that's not illegal, but now you're going to have the natural log of a half, which we can't really evaluate, and then you'll have to eventually e both sides and convert it anyway. There you go. Yeah, nice. So does that make sense, Cole? Yeah. Okay. So yeah, whatever that comes out to be. All right, the next one. We got z to the second equals 25. So whenever your unknown is the base, now when you convert it to exponential, it turns into a polynomial. Good job today as well. So now we have a quadratic, and when we take the square root, we consider plus or minus, but do we want the negative in this case? It's either -5 or +5 when you take the square root of both sides. In this context, we're finding the base. Can we have a negative base? No. So we considered it, and then we said, get out of here. And the answer is just 5. Okay. And on the last one here, ay caramba. Convert it. 5 to the zth power equals 5 1/25. Now there is a 5 on both sides. Will one of them divide out? If you're fancy like Applebee's on a date night, like Walker Hayes.
I mean, you could simplify it down to 5z is equal to 1/25.
Ah, that's what I would do. If you just try to divide out a 5 from both sides, you would get 1 1/25 over here, but then you'd end up with 5 to the z minus 1 power over there. Would anyone do that? Probably not, right? That's like dividing both sides by a 5. So what I would do instead, that's fancy, okay? I would just simplify. 5 1/25 simplifies to 1/25. Yeah. And now get the base is the same. Get the base is the same. That's the same as 1 over 5 squared. And now I bring it to the top and I get 5 to the -2th. And now we either take the log base 5 of both sides algebraically, or we use the fact that 5 to the z is 1 to 1, and we use the GTBTS theorem, which would say, so z equals -2. Is this important if you use the GTBTS? It is. Okay, so get in the habit of writing that. It's not an algebraic consequence. If you want to take log base 5 of both sides, then you wouldn't have to write so. That's algebraic consequence. It's a little nuance to mathematical communicating. So therefore would be another way. Therefore, right? Ergo, consequently. And then finally, in summary, what would be another way? What? In conclusion. Very nice. Nice. Very good. In conclusion. To wrap this up, yeah, in closing, finally, at last, after all of that, yeah, we arrive at, yeah, okay. So if I start right now with graphs, I'm not going to finish. So we'll see what happens. Would y'all like the worksheet to be due Friday or Monday? What would be better? If I make it due Friday, you get it done, you buckle down, you get it done, you get your weekend freed up. If I make it due Monday, you have more time to complete it, but really you're just going to be doing it Sunday night. Right? Right? True that. Yeah. Let's make it due Monday. You know why? Because y'all are young adults and I want to give you the responsibility of managing your own time. You could still do it and get it done tomorrow night and have it done by Friday and still not have to do the weekend. So try to manage your human nature of procrastination. I'll make it due Monday. So the worksheet is going to be due on Monday. So tomorrow I won't be here, but I will be here in spirit and in voice. I will have the substitute hit play on a video that'll be on my desktop. I'll have the central speaker kind of loaded. Yeah, go ahead and clear your calculator. Remember, second plus, number 7, reset all, and then confirm. And the video might take the whole period. It might finish beforehand. But again, if there's any time left over, feel free to work on your worksheet. Okay. Logs. We love the logs. Give us some logs. And then I'll be back on Friday. Okay. Any questions? All right.